So good morning, everyone. I present myself. I'm Oussama Hamel from the university. I'm a PhD student from the University of Blida 1 in Algeria. So I did this work with my supervisor, Mrs. Fareh, from the same university. So I'm here to present our paper entitled Encoder-Decoder Neural Network with Attention Mechanism for Type Detection in Linked Data. So before presenting our solution, I would like to cite the main titles of this, or the main sections of this presentation. So I will start by an introduction to link data. Then I will talk about the limits of related works and our contributions. Then I will describe the details of our method and the experimentation phase. Then I will illustrate illustrate the results with the discussion, and I will end this presentation with a conclusion. So let's begin our introductions. So first of all, I would like to recall the definition of linked data. So linked data is a set of principles for publishing and connecting data in the web through semantic links. As you know, with the emergence of use of this representation of the data, many applications use it as a medical application, commercial application, and so on. The advantage of this representation is the capacity of using the inference engine and the ontologies in order to generate more knowledge. However, we have a problem with the linked data, which is the uncertainty. Which is by uncertainty we mean ambiguity, false statements, data imprecision, and data incompleteness. Let's focus on this type of uncertainty. By data incompleteness, we mean that in the data set we have so missing statements. And now let's talk about the research problem. So before talking about the types detection problem, let's recall that the linked data dataset built according to linked data principle is composed from a subject, an object, and the predicate, or the link between them. For example, Bob knows John. Here we can see the subject, Bob, the relation knows, or the predicate, and the object, example. So here, now I will explain our research problem. It's about one of the most important tasks to deal with linked data incompleteness, which is in order to deal with linked data incompleteness, which is the missing types prediction. This means how can we predict the types or the classes of the subject based on the informations or triples contained in the data set, and then eventually using the ontology and the inference engine in order to generate more data. So let's talk about the related works limits. So the main limitation of the related works are the first point, the papers who deal with the type detection problem don't give weights to the more significant triples in the data set when trying to detecting the type of subject. So they treat all the triples the same way. Second point, they don't extract the semantic relation hidden between the triples in the dataset. Third point, we notice that the results are insufficient, so we can improve this result. And here comes the motivations of our work. So by treating this problem, we will be able to decrease the data set incompleteness. And the many application using this kind of data set, so will give more accurate results. The third point, we use the deep learning to techniques to deal with this problem because it's the best way to deal with big data or large amounts of data. So for our contributions, so we propose a neural network for the multi-label classification in order to predict the types. So in this neural network, we used the attention mechanism in order to give weights to the more important triples when generating types, and in order to extract the relation between the triples. I will explain this in the architecture of our model. Third point is we use a sequence-to-sequence model as we consider this problem as a sequence-to-sequence problem. So we will use a sequence of triples as input and a sequence of types as output. The last point, so we used RDF2VEC, RDF2VEC, or numerical representation, in order to transform the triples and give numerical representation. So now we will pass to the method description. We start by our pipeline. So we started by reading the data set. So we read all the triples of the data set, then we convert them to the numerical representation. Then we fed this numerical representation to the neural network in order to train it. The next step is the test of our model, and then we will be able to predict types for linked data. Now let's talk about our model. So our model is made up of two big parts, the encoder part and the decoder part. Each part contains an embedding layer, as you see, in order to reduce the one-hot representation of inputs and of the inputs of the encoder and decoder. So we used it in order to reduce the one-hot representation, and we used the GRU cells in order to treat the problem as sequence-to-sequence problem. So let's talk about the input and the output. So for subject for a given subject S, we use all the predicates and object in relation with this object as input to predict the types because the subject can have multiple types in order to predicate the types of this subject. So here we use the attention mechanism. By using the attention mechanism, so we can generate multiple hidden states in order to generate the context vector. In the context vector, each context vector generated contains the weights of every input, and by using these weights, we can next predict the types. So every type here is connected with the inputs by the weight. So the weights give they give the importance of each input when generating the output. So for each output, we have a specific context vector with the attention weight. And here we use a softmax in order to generate from all the possible types. We generate the type with the higher probability. So we use the softmax function in the output layer. For the experimentation, so we use the dataset DBpedia for the training and the test of our model. So we use 60% for the training, 20% for the validation, and 20% for the test. We trained our model on the Google Colab platform, which contains 12 giga of RAM, and the GPU is accessible 8 hours per day. So we use the TensorFlow and Keras and Python and the Python language in order to write our program. For the hyperparameters, so we use the Adam function as optimization function. We use the sparse categorical cross entropy as loss function. For the number of GPU nodes, of GRU nodes, we use 1024 nodes. The batch size equal 64, and binding size equal to 256. Now let's illustrate our results. So this histogram illustrates the results of comparison of our model with another model without attention mechanism. So here we are trying to show the importance of using the attention mechanism in the types prediction task. So as you see, our model outperforms clearly the model without attention mechanism. We calculated the precision, the recall, and the F measure. We can interpret these results by the capacity of attention mechanism to give weight to every input, and its capacity to extract the relation between inputs. We call this the self attention, and the relation between inputs and outputs. We call it the global attention. as you see, by focusing on some elements in the output, so we can improve clearly the task of type detection, and by the manner we represented data helps a lot in to have this result by using all the triples in input and generating the types in output. As conclusion, we can say that the incompleteness in linked data is a very important problem because every lot of applications use this style of representation of data. The type detection using the neural network with attention mechanism is a very effective way to treat this problem. We need, as future works, we need to deal with the remaining types of uncertainty in linked data, and we need also to find solution to filter the generated types. We need to find automatic mechanism in order to say which types are correct and which types are not correct or are incorrect. Here are some references for you. And thank you for your attention. I'm looking forward to answer your questions. Thank you.
Thank you, Oussama.
Welcome.
Are there any questions? Yeah, I see one hand, Franziska.
Yes, thank you. I understand that you use the DBpedia to train and test your model. And I was wondering if the model has already been tested on other databases. What were the results, or what do you expect when you perform the tests in the future on other databases?
So the model, you are right. So you're right. So the model was tested only on the DBpedia dataset. We tried to test it in other datasets, but from the dataset mentioned in the related works, but most of them are unavailable this day. But we think that if we test our model in the future in the other dataset, we think that we will have a good result.
Thank you. And I have a quick question. The topic is very interesting, but it would be fitting for a number of FETSIS tracks. So why did you choose DSH, right, which stands for Data Science and Health, Ecology and Commerce? And could you give an example how to use your approach in any of those three fields?
Yes, for example, in medical fields, most of data are stored in different systems. So we can use the linked data representation in order to align or mapping this data from different sources, and then use these techniques for dealing with the data incompleteness in order to generate more data and generate more knowledge for data set.
Okay, thank you.
Thank you.